we are working on lesson number 5 and 6. So first, let's get started with understanding the negative exponent and how to use or write in scientific notation. Now, the scientific notation, it's a way of writing an extremely large or extremely small number in a simplified version. And you are writing a decimal between 1 and 10, and you are multiplying by the power of 10. So the first number must be in between 1 and 10, and you multiply with times 10 to an exponent of something. So for example, on the left, we have a speed of light. So it looks like it's a very, very big number. Okay, so we have 300, 1, 2, 3, 4, 5, 6, 7, 8. So we have 300 million meter per second. So what we need to do is the decimal is over here, and the invisible decimal, and we're moving by 1, 2, 3, 4, 5, 6, 7, 8. So the decimal should always be after a number that is in between 1 and 10. So it's 3 times, we moved 8 steps. So because it's a big number, it's 10 to the 8. What about a mass of a proton? So as you can see, it's an extremely very small number because it's 0 point something. So what we're going to do from the decimal, we're going to move to the first non-zero number. So let's see, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19, 20, 21, 22, 23, and then 24. So I stop at 1 because, like I said, the decimal point should be after non-zero number. So it looks like we moved 24 steps. So our decimal is now at 1.76. So 1.76 times 10 to the, because it's such a small number, we put negative 24. Okay, so if it's a big number, like greater than 1 or 0, it's a positive exponent. But if it's less than 0, then it's going to be negative exponent. Okay, so let's try this. So number 1a, it says express in standard form. Standard form means get rid of the exponent, so don't write it in scientific notation. So it looks like it's a big number. It's 10 to the 5, so we're moving to the right from 1.6. So from 1.6 here, the decimal is here, we're moving 5 steps. So 1, oops. So we're doing 1, 2, 3, 4, 5. So within the point, we're filling in the 0 here. So 0, 0, 0, and 0. Okay. So if I have to write this down in standard form, it will be 160,000, like this. Okay. Now what about letter C? So it looks like it's 10 to the negative 8. So it's going to be a small number. So we are moving, so 2.1 is here. So we're moving to the left. If it's negative, it's getting smaller. So by 8 steps. So 1, 2, 3, 4, 5, 6, 7, 8. So this is my decimal here. And now I'm going to fill in the 0 in the spaces that here, empty space. So 1, 2, 4, 5, 6, 7, and you need to have 0 right in front of a decimal. Okay, so therefore my final answer will be 0.123, 123, 121. Okay, so that's how the standard form of a number looks like. Okay, Now, what if I want to convert back to a scientific notation? So scientific notation means, like I said, it has to be 1 and 10, the first number, and multiply by the base of 10. So for number 2a, we have a very big number. So that means there is an invisible decimal over here at the end of the number, and we're going to move to the left. So 1, 2, 3, 4, 5, 6. Okay, so I stop as soon as I hit a the first number. So it's 5.3 times 10 to the, how many steps did I move? So 1, 2, 3, 4, 5, 6. So 10 to the 6. That is my scientific notation. Okay. Now what about number 2b? So it's a small number, and I see a decimal here. So we got to move to the right until a number between 1 and 10, which is 8 here. So 1, 2, 3, 4, 5, 6, 7. So I moved 7 steps. So it's going to be 10 to the negative 7 because it's a small number. And I stopped in between 8.02. And then whatever the number, you just write the rest of it. Okay. Now for letter C, it's a little bit different. Why? Is because the problem with this one is that it's 54.1. But do you remember the first rule? I said that the number must be in between 1 and 10. So 54 is bigger than 10. So it must be, I have to reduce it. I have to go to the left by making it 5.41. Okay. So if I move to the left, right? So what's happening, the number I have to, so I could convert this 54.1 to be 5.41 times 10 to the 1, because we're moving to the left, right? So if we're moving to the left this way, the number, the exponent is getting bigger. But if I'm moving towards the right, the exponent is getting smaller, to put it in scientific notation. So 54.1 is exactly the same as 5.41 times 10 to the 1. And then times, we have 10 to the negative 5. So you will notice that we have a like term, the exponent law. So when you're multiplying, you add the exponent. So 5.41 times 10 to the 1 plus negative 5 is negative 4. Okay. So that's how you simplify so that there's only one number between 1 and 10. So if you look at letter D, there is also a problem here. The problem is the first number is 0. We can't have 0, right? It has to be between 1 and 10. So that means I have to move the 0 to the right by 2.82, right? So the first number is 2, not 0. So if I move to the right, that means it's getting smaller. So it's 10 to the, I move 1 step, so it's negative 1. And then I originally have times 10 to the 9. Okay. And then we're going to use the exponent law. We're adding the exponent because we're multiplying with the same base. So it's 2.82 times 10 to the 8. Negative 1 plus 9 is 8. Okay. So let's try a question that involves, let's say, division. Okay. So number 3a. So if we have express each number in scientific notation, and then simplify using the exponent law, and then evaluate. Okay. Now, so what we're doing here for the first one, we are multiplying. Okay. So the numbers are very big. You could put it in a calculator, but first, what I want you to do to simplify, put it in scientific notation for the first term. The first number, so there's invisible decimal here. So it looks like 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. So 4.0, or you could write just 4, right? Because there is 4 decimal here, invisible. And then times, we moved by 10 steps to the left. So it's positive number. And then times, so we're going to the right. So it's going to be a negative number because it's a small number. So 1, 2, 3, 4, 5. I stop when I have non-zero. So it's 3.2 times 10 to the negative 5. So now we are going to apply the exponent law where we have 4 and 3.2. So when we multiply that, it's going to give me 12.8. And then we have 10 to the 10 times 10 to the negative 5. So what we're doing, we are adding. So 10 plus negative 5 is going to give me 5, right? We're adding it. But the problem is the last step, again, the first number is not between 1 and 10, it's 12. So that means we have to move this decimal one more steps to the left. So it's finally 1.28, 10 to the, because if we move to the left, what did I say? The exponent is getting bigger. So we moved 1 to the left by 1 step, so the exponent now becomes 6. Okay, because we moved 1 step. Now let's try letter B, 3B. So let's convert the first number to a scientific notation. So decimal is here, 1, 2, 3, 4, and 5. So I stopped at 3.2 times 10 to the negative 5. Okay, we move to the right. So it's becoming negative. Divided by, so it's a big number, so there's invisible decimal here. We're moving to the left. So 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. So 4.0, or you could just write 4. And then times 10 to the 10. Again, same thing. We have our like term, so 3.2 divided by 4. So 3.2 divided by 4, it's going to give me 0.8 times, so we're going to do 10, negative 5, minus, because we're subtracting, minus 10 to the 10. So it's going to be minus 10, right? Division, you're subtracting. So it's 0.8 times 10 to the negative 15. But we're not finished yet. The reason why is because the first number is not 1 in between 1 and 10. So it's 0. We don't like that. So that means I have to move this decimal towards the right. Okay. So now finally it's 8 times, if we move to the right, the exponent is getting smaller. So by one more step. So negative 15 minus 1, it's getting smaller. So it becomes negative 16. So that will be your final answer. Okay. So you will try example 4 on your own. So make sure you double check your answers. Now we are going to go through negative exponent and algebraic expressions. Okay. So simplify using algebraic expression. So everything is pretty much combined. It will be like a good review. So let's take a look at number 1a. So it looks like we're multiplying and dividing the same base. So the base here is x. So 2 multiplying means plus negative 5, and then dividing x to the 1. So that means that I'm subtracting minus 1. So when you put everything together, x 2 plus negative 5 minus 1 will give me negative 4. But we don't like negative exponent. We have to put it in positive exponent. So using the exponent law we learned before, a to the negative n is equal to 1 over a to the n. So what we're going to do, I'm going to flip x, take the reciprocal, so it's 1 over x, and negative 4 now finally becomes x to the 4. Okay, so you could write it like this, or you could write 1 over x to the 4. It's same thing. Okay, now let's try letter E. So if we look at letter E, we're dividing this time. So we are going to do the coefficient first. So negative 36 divided by negative 9. So negative 36 divided by negative 9 is going to give me 4. And then we have a like terms, which is x and x, and y and y. So for x, 3, so we're subtracting because it's dividing, minus negative 1 here, negative 1, and then y to the 4, it's dividing, so we're subtracting again, and then minus 4. So I put negative 1 because there's negative 1 here already. Okay. So then 4, x to the negative becomes positive. So 3 plus 1 is 4. Y, 4 minus 4 is 0. And you notice that we can apply the exponent law where we have anything to exponent of 0 is 1. So therefore it's 4 to the x to the 4, y to the 0 is 1. So therefore my final answer is 4 to the x4. Okay. Now let's try letter G. For letter G, I notice that we have a negative exponent outside, and then we also have multiplication here. These two numbers they're multiplying. So therefore, what I'm going to do is I'm going to do bedmass first. So do the brackets inside the bracket and then do the exponent. Okay. So the equal sign. So 2 times negative 3 is negative 6. And then x, 2 plus 4, because we're multiplying, it's going to be 6 to the power of negative 2. And now I'm going to apply the exponent law. So what you could do is you could flip it to make it positive exponent, or what I'm going to do is I'm going to apply negative 2 to the 6 and to the x. So it will become negative 6 to the negative 2, x to the 6 to negative 2. And now I'm going to apply negative 6 to negative 2. So I'm going to flip it first. So it's going to be 1 over negative 6 to a power of 2, right? Negative exponent. And for this one, I'm not going to flip it right now. I'm just going to multiply these two. 6 times negative 2. So it's x to the negative 12. And then negative 6 times negative 6 is 36, positive 36, because negative becomes positive. And then for this one, I'm going to flip it because I don't like negative exponent. So let's flip x, so it becomes 1 over x to the power of 12. So we have to put everything together. It's 1, because it's 1 times 1 for numerator, and for denominator is 36 x to the 12. Okay. Now, then, lastly, let's take a look at I. Okay, so again, bed mass. I'm going to simplify inside the bracket. So it looks like for coefficient, I have 4, but for denominator, it's just invisible 1. So 4 divided by 4 is 4. And then m, so it's 4 minus 1, right? Because it's subtracting, dividing. And then for n, it's -9 minus -2. And then power of -3. So let's simplify. So 4m to the 3, and then for n, -9 plus double negative becomes -7, and then -3. And then after that, I'm going to apply this exponent law to the n, to the m, and to the 4. So therefore, it's going to be now 4 to the -3, m, 3 to the -3, and n to the -7 to -3. Okay, so let's apply the exponent law. So I don't like negative exponents. I'm going to take the reciprocal, 4, and finally becomes positive. And for m, I'm going to multiply these two, so -9. And then these two for n, I'm going to multiply n to the 21. So it looks like n is positive and m is negative. So I just need to do 4 to the 3. 4 to the 3 is 64. And I'm going to take the reciprocal for m, and it becomes positive, times n to the 21. Okay, so it looks like, keep in mind that n to the 21 essentially means it's over 1, right? So for my numerator, it's 1 times 1 times n21. So its numerator is n21. And for my denominator, I have 64 times m to the 9. And that is your final answer.